Anchors have existed for nearly as long as ships themselves, and for a very good reason. These massive pieces of steel are responsible for keeping vessels securely fixed in place, preventing them from drifting due to strong currents, rough seas, or powerful winds. While anchor designs vary, most use large flukes that dig deep into the seabed, creating a powerful grip capable of holding thousands of tons of weight. And when it comes to some of the largest ships ever built, the scale of that grip becomes absolutely staggering. As a general rule, the larger the vessel, the larger the anchor must be. Modern aircraft carriers can stretch nearly 1,000 feet in length and displace well over 100,000 tons when fully loaded. Holding a ship of that size in place requires an anchoring system that is nothing short of enormous. A single carrier anchor can weigh around 30,000 pounds. Attached to it is more than 1,400 feet of heavy steel chain designed to withstand years of punishment from salt water, friction, and extreme loads. With so much depending on these components, routine testing and maintenance are critical. Unlike smaller boats, large warships cannot simply toss an anchor over the side and hope for the best. Instead, they rely on a sophisticated anchoring system that extends through multiple decks of the ship. At the lowest level sits the chain locker, a massive compartment where hundreds of feet of anchor chain are stored while the vessel is underway. From there, the chain passes upward through reinforced openings toward the windlass room, where the machinery responsible for controlling the anchor is located. Every movement of the anchor is carefully managed. At the heart of the system is the windlass, a powerful winch specifically designed to lower and retrieve thousands of pounds of steel safely. The chain passes through specially shaped wheels known as wildcats, which grip each link securely as it moves through the system. These components don't just control movement, they also serve as part of the braking mechanism, helping operators manage the tremendous forces generated whenever an anchor is deployed. To ensure everything is functioning properly, crews regularly perform anchor drop tests. During these inspections, the anchor is first lowered in a controlled manner, while technicians monitor the performance of the windlass, brakes, and chain handling equipment. Once the initial checks are complete, the anchor is recovered and prepared for additional testing. The next phase can be even more demanding. The anchor may be released under carefully controlled freefall conditions, allowing crews to verify that the braking system can stop its descent within the strict operational limits. Measurements are taken, adjustments are made if necessary, and the process is repeated at different chain lengths. Only after every component performs within specification is the system considered ready for service. The reason for such extensive testing becomes clear when considering the extreme conditions these systems face. Anchor chains are subjected to tremendous stress throughout their operational lives. Every deployment generates friction between moving components. Every recovery places immense loads on the chain, and every day at sea exposes the metal to corrosive salt water. Over time, even high-strength steel can begin to show signs of wear. Small cracks can form. Corrosion can weaken critical areas. Individual links may become distorted after years of heavy use. Left undetected, these seemingly minor issues can eventually lead to catastrophic failure. That is why routine inspections are so important. When a ship is underway, sailors often conduct manual chain inspections inside the confined spaces of the chain locker or windlass room. Working around massive lengths of steel chain in these environments can be physically demanding and requires constant attention to safety. During major maintenance periods, however, the process becomes far more extensive. The entire chain may be removed and laid out across a dock, allowing inspectors to examine every individual link. Technicians carefully search for cracks, excessive wear, corrosion, damaged shackles, and loose connecting hardware. Nothing is overlooked. Every link, every fitting, every connection, because if even a single weak point goes unnoticed, the consequences can be severe. A failed anchor chain could leave a ship unable to secure itself during rough weather, emergency situations, or critical operations near shore. For a vessel carrying thousands of personnel and billions of dollars worth of equipment, that is a risk no crew is willing to take. Yet the anchor system represents only a small fraction of the maintenance required aboard a modern aircraft carrier. These floating cities contain millions of moving parts. Aircraft elevators, electrical systems, propulsion equipment, communications networks, launch systems, and countless mechanical components must all operate flawlessly, often while deployed far from support facilities. Among the most important systems aboard the flight deck is the arresting gear. Landing a high-speed aircraft on a moving ship is one of the most demanding tasks in military aviation. Pilots have only seconds to execute a perfect approach, and just a few hundred feet in which to stop. Without specialized equipment, such landings would be impossible. The arresting system consists of a series of heavy-duty cables stretched across the flight deck. As an aircraft touches down, a tailhook mounted beneath the fuselage catches one of these cables. What happens next takes place in mere moments. The aircraft's forward momentum is transferred into a complex network of mechanical and hydraulic equipment located beneath the deck. Massive energy absorbers convert the aircraft's kinetic energy into controlled resistance, rapidly slowing the aircraft while minimizing stress on both the machine and the pilot. Within seconds, an aircraft traveling at high speed is brought to a complete stop. Technology based on the same principle is also used at military airfields around the world. Unlike carrier systems, land-based arresting gear is typically intended for emergencies. If an aircraft suffers brake failure, landing gear damage, or another critical malfunction, these systems provide an additional means of stopping safely before reaching the end of the runway. The concept remains remarkably similar. A strong cable is stretched across the runway and connected to specialized braking equipment. When the aircraft's tail hook engages the cable, the energy-absorbing system immediately begins slowing the aircraft. In many situations, this technology can mean the difference between a safe recovery and a devastating accident. But just like shipboard systems, runway arresting gear must be maintained with absolute precision. The forces generated during an emergency stop are immense. Every cable, connector, pulley, and braking component experiences extraordinary stress. Any failure at the wrong moment could place pilots, aircraft, and ground crews at serious risk. As a result, maintenance and testing are conducted on a regular basis. Technicians frequently use heavy vehicles to simulate the forces generated during real aircraft recoveries. By repeatedly pulling the cables under controlled conditions, they can evaluate performance, verify braking efficiency, and identify potential problems long before they affect operational readiness. It is demanding work, but essential work. Whether securing one of the world's largest warships to the ocean floor, or bringing a high-speed aircraft to a safe stop during an emergency, these systems perform critical tasks that most people never see. Behind every successful deployment, every safe landing, and every secure anchorage stands a team of highly trained personnel dedicated to inspection, maintenance, and preparation. Because in environments where failure is not an option, reliability is everything, and reliability is built through constant testing, relentless attention to detail, and the expertise of the crews who keep these remarkable machines operating day after day, wherever duty takes them.